Hi, in this video we are going to explain the resolution analysis protocol of the SPOC plugin. This method has been developed by Maximilian Beckers and Carsten Sachse. If you use this protocol, please cite this reference. The Fourier shell correlation, or FSC, is the standard resolution metric in cryo-EM. However, the resolution determination step is still subjective and not fully automated. This is because it involves a series of map interventions before the FSC estimation. Also, the proper threshold of the FSC has been subject of discussion for many years. The protocol we are going to explain uses statistical methods of permutation testing and false discovery rate control to the resolution-dependent correlation measure. The approach allows fully automated and mask-free resolution determination based on statistical thresholding of the FSC curve. The first step is to import the data in Scipion. We can import the data with the left side panel and the protocol import volumes. We do double click and a window is open. This window requires the path to the volumes. We can browse in our computer by making click in the folder icon. So we go to the place where the half maps are located, and we will import the TRPV1, the two half maps that corresponds with the EMDB entry 5778. We select the half one, and the halves have a pixel size of 1.215. And to be tidy, we will put a label saying that this is the half one with this icon. Once the form is fulfilled, we do click in execute and a box appears. Once the box is green, the protocol ended and the volumes are available here below in the summary. So you can see how the output is an object of type volume with these dimensions and this sampling rate. We have to do the same with the second half, and in this case we mark the box and we do right click, copy, and we have to provide again the path of the second half. In this case here, select. Same sampling rate, and we change the label by making click here, half 2, and execute. If you are in the middle of an image processing, you don't have to import the two halves. Scipion manages the two halves behind. So in that case, the two halves are associated to the full map. Once the two halves are imported in Scipion, we can use the resolution analysis protocol. So the protocol is located in the left side panel in 3D, analysis, resolution analysis of the SPOC. We do double click and this window is open. So the protocol asks if the two half maps are stored with the input volume. We say no because we imported the two half maps separately. After processing this, we will say yes, and we will check what happened. So we select the first half map by making click on the lens, and we select half map 1. And we do the same for the second half by making click in the lens and selecting the second half. The bold parameters means that they are mandatory. And let's say that local resolution, we want that the local resolution will be estimated by setting yes. More parameters appears like the symmetry. The TRPV1 has C4 symmetry, so we type C4, and the rest of parameters are a mask that is optional and the resolution range. So we do click in execute and the protocol starts to compute. Now we have this box. Yellow means that is processing, and below we can see how the input of this box are the two half maps and the output is empty because it didn't finish. Meanwhile, we have here the methods with a link to the journal, to the publication of this algorithm, and the output log. The output log tells me all commands that are launched in the terminal. Like in this case, this. If I copy exactly this command line in the terminal, I will get the same result. But we are using Scipion. As I said before, if you are in the middle of image processing, then you don't have to import the half maps. You can take the output of your refinement step, for instance, and you can run the resolution analysis. How to do that? Okay, let's simulate that we are in the middle of an image processing. So I'm going to import volume, but this volume will have associated the two half maps. So here I select the map, and in this case I select the full map. Okay, and this full map has associated the two halves, and I will say yes. And now I have to provide the path of the two half maps. So the first half here, and the second half here. And the sampling rate is 1.215. This means that, let's see the output. Execute. That we are importing a volume that is a full map, but in the summary appears that it says this with halves. If we compare with this other import, has no halves because it's a single map. But in this case, the full map has also associated the two half maps. So when you are in the output of the refinement step, your output has associated the halves. And now if I execute the resolution analysis, I go to resolution analysis, double click, I can say, are the half maps stored with the input volume? Yes. And the unique parameter, the unique entry that appears is the volume with half maps. And if I do click in the lens, I can select the unique volume here that has associated halves. You can see with halves here and select. And now I can do click on execute. Let's specify that this was with halves. And we do click in execute and the box appears. If I do click in this tree, the protocols are arranged and it will take a bit of time. Once the box are green, the protocols ended, and we can see how each of them provides different outputs. So in this case, in the case of the full map with halves, the output is a single FSC. This is because if we do double click on the box of the protocol, we say that the estimation of the local resolution was set to no. But if we do the same with the left one, with the ones with the two separated halves, there is an additional output that is the local resolution map that is here. And this is because if we open the protocol, we say yes to the local resolution. To analyze the results, we can select the output and do right click and open the output with the data viewer, for instance. And the local resolution map is open in slices. We can select any of these slices and double click, and ImageJ opens this slice, and we can use different ImageJ features to analyze the map. But it is much more convenient to do click in Analyze Results, the red button here, and a window, and a specific viewer is open. So in this case, we can do click on Display the FSC curve, and this window is open. This window provides the FSC curve with the false discovery rate, and the original axis you can find the inverse of the resolution. The second window that is open is the same FSC curve, but with the horizontal axis in Armstrong. You can also open the local resolution map in slices by making click in this eye icon. That is the same slices as you observed before, and you can open the slices in color. So if you do click in the eye, and the window with the color slices by local resolution values is open. However, in some cases, we don't want to use this scale, and we prefer to use other color map to highlight some specific features of our map. In that case, we close this window. We can select the color map with this wizard by making click in the rod, the wizard open, and here in the color set we can select a color map in a list. If we do click in any of them, the color is updated. For instance, we are going to use Viridis, that is an unbiased color scale, and we do click in OK. So now if we open again the color slices, they are colored with this color map. Next feature is that we can open the color slices along different axes. We opened before along the Z axis, but perhaps we are interested along the Y axis. So we select the Y axis and do click again on colored slices. And this is a different view. If we observe this scale, we see that 1 Armstrong is yellow and 10 Armstrong is blue. But Nyquist, looking at here, and the sampling rate is at 2.4. So perhaps we want to get a narrow color scale. We can do that by selecting the highest resolution at 2.44. That is Nyquist. And now we are going to visualize the color map in Chimera by making click in the eye here. And it can take a few seconds, but Chimera will open, and here it is. And we will be able to observe our protein with the local resolution in the range between 2.44 and 10 Armstrong, and the surface color by resolution. We can put a lower threshold to visualize better the different features. And this is all about how to color the maps. It remains this option, color a sharpened map by local resolution in Chimera, that in many cases, for instance, for publication or for tracing in modeling, we are interested in color a sharpened map instead of the raw maps. So here with the lens, you can select a different map to apply the color surface in Chimera. And this option allows to select a different map to represent the resolution map color in Crimea. And this is all about the SPOC plugin. Thank you.